A linear function. So we know linear functions like y equals mx plus b, or instead of y you can have f of x. The y-intercept is 6. Which one would that be? Okay. So b, y equals 3x plus 6. The 6 is your y-intercept. So y-intercept of 6 is b. A vertical line. What's the equation of a vertical line look like? That's, yeah, if it's x equals a number, that's vertical. Right, if it's y equals a number, it's horizontal. So we need just x equals a number. So that is h. A constant function. All right, we have talked about increasing, decreasing. Constant is no change. So that's a horizontal line. A horizontal line is y equals a number. So we're looking for the one that's just y equals. So which would that be? C. F of x is the same thing as y. All right, the next one. What do I mean when I say x and y intercepts? Okay, where we hit the x and y axis. So if I hit the x-axis at -2, what point is that? -2, 0. I hit the y-axis at 4. What point is that? So I'm looking for the graph that both of those points would work. Which one would that be? G. If I put in -2 for x and 0 for y, I get -4 equals -4. If I put in 0 for x and 4 for y, I get -4 equals -4. So that one works. If it passes through the origin, what's the origin? 0, 0. So which one would 0, 0 be a point on? A. Your y-intercept is 0. Not linear. So we know linear is y equals mx plus b. Which one doesn't follow that pattern? D, because it's a square. What's x squared look like? Parabola. All right. Next ones. How'd you guys do on the first 6? Did we miss some? No? Okay. So these, you just have to know. Y equals is what? Horizontal. So y equals 5 means a horizontal line at 5. So that would be A. Y equals -5 is a horizontal line at -5. So that's C. X equals a number is vertical. So x equals 5 is a vertical line at 5. So that's D. X equals -5 would be a vertical line at -5. So that one is B. Did we get those? Last 4. Make sure if you have something else open on your Chromebook, you're closing out of it and paying attention to what I'm doing here. Okay, we want to know which of these would have the given slope. 1/3. First of all, 1/3 is positive, so my line needs to be, right, positive slope. It's increasing. So the only ones that are increasing are D and E. So if I look, it could be 1/3. The other positive number I have is 3. How do those things compare? Okay, which one would be more steep? The 1/3 or the 3? 3, because that's like up 3 and over 1. So 1/3 is up 1 and over 3. That would be your flatter line, so that's got to be D. 15 would have to be E because it would be steeper. All right, so my two negative slopes. We have a -3 and a -1/3. So if I'm looking at my graphs that have a negative slope, that means they are decreasing. So that's either C or F. -3 would be the steeper, so that one is C. -1/3 would be flatter, so that one is F. What kind of line has a slope of 0? Horizontal. Rise over run. Your rise is 0. Undefined is like a number over 0. So it goes up but doesn't go over. So that's a vertical line. So that one is B. Okay, how did we do? Okay? All right. Then you can return to your seats, and I just need you to get out your notes for a minute. It tells me in 2006, about 60 billion text messages were sent in the United States. During the next 6 years, text messaging increased. Did we do this one?
No.
We didn't. Huh?
We got all these already.
Oh, whatever. During the next 6 years, text messaging increased on average by 407 billion messages per year. Okay, I need to know what M and B are so that I can write an equation. What does M represent in an equation? Slope. Rise over run. The key to that is slope is a rate of change, so it's something per something. Look back in your problem. Where do you see something per something? Messages per year. That's a rate of change, so that has to be my slope. So my M is my 407. I'm not going to put the zeros, I'm just going to note in a second that that's in billions, because it tells me my equation has to be in billions. All right, what does a y-intercept represent? Where it starts. Okay, where it hits the y-axis. So when we started this was in 2006. In 2006, how many were sent? 60 billion. So my equation would be y equals 407x plus 60. And that would give me an answer in billions. So whatever I got out, I know my unit is billions. So the next question. If I were to know the number of text messages sent in 2012, my number of messages is my y, that's what I'm trying to find. So I need to know what number to use for x. I don't just want to do 2012 though. What do I want to do? Why 6 years? Right, we started in 2006, so we were treating that as time 0. So 2012 is 6 years later, so my x is 6. So if we plug that in. Alright, grab calculator if you need to. If you don't have one, go ahead and get it. What would my units be? That would also be correct. Questions on that one? Let's look at this problem. A skydiver is 1,500 feet above the ground after 5 seconds and 2,500 feet above the ground after 15 seconds. Find and interpret the average rate of change. Okay. What's another word for average rate of change?
Slope.
Slope. So I'm asking you to find a slope. I didn't just give you the slope in the problem because you don't see something per something, so we have to figure it out. What information did I give you? Not even necessarily because I don't have it. But I have the information to write ordered pairs, don't I? All right. Your x value should be your time. So after 5 seconds, what was my height? And after 15 seconds, what was my height? How do we find slope? Rise over run. Remember we talked about formula y2 minus y1 over x2 minus x1, which was your x1 y1 is 2, y2. So, all right. I have my average rate of change. That's my slope, it's 100. But when I say interpret it, you have to tell me what that means. So first of all, this is a positive number. So what does it mean? We are increasing. Okay? We need units here. Think about how we did this. We did y over x. What were the units on my y values? Feet. What were the units on my x's? And a division line is like saying per. So it's 100 feet per second. So the interpretation is the height is increasing because it's positive. feet per second. So if I'm asking you to interpret, you have to use your number, and I expect units. Tell me what units would be used on that rate of change. Question 6. Okay, so just kind of a heads up for the week, what we have going on. This is the end of section 3. Tomorrow, I will teach section 1.4. Thursday, we will have a quiz over everything that we've covered so far in this chapter. So 1.1 through 1.4. So remember, that was like going back, Pythagorean theorem, distance midpoint formula, talking about relations and functions, domains and ranges, if something's a function or not, and then all the linear stuff that we've been doing, slopes, intercepts, rates of changes. Tomorrow we'll talk about the equation of the line a little bit more, writing the equation of the line, which should be just a review for you. So, we will have a quiz on Thursday this week. Friday I opened up a Math Excel assignment, so you guys have the rest of the hour to work on that and finish it up and ask questions if you need to.